All right, welcome. Today we are diving into one of the most incredible construction projects you can possibly imagine, building the human digestive system. We're going to look at it like it's the ultimate assembly line, a process that takes one simple tube and turns it into this complex factory that's designed to handle everything we eat. So let's get right into it.
And really, it all boils down to this one big question. I mean, it sounds kind of impossible, right? How does a single, straight tube manage to turn into an esophagus, a stomach, and all those meters of coiled-up intestines, all sitting in just the right place? Well, that's the amazing puzzle we're going to solve together today.
So here's our game plan. We'll kick things off with the initial blueprint. Then we'll tour the three main stations on our assembling line: the foregut, the midgut, and the hindgut. And to finish up, we'll take a look at the all-important quality control department to see what happens when something on the line doesn't go quite right.
Okay, first things first, you gotta lay the foundation. Before you can build any of the complicated stuff, you need the basic structure and the raw materials all lined up. This is where it all starts. The real action gets going in just the 4th week of development. The embryo, which starts out as this flat little disc, starts folding in on itself, both from head to tail and from side to side. And this folding process literally traps a piece of the yolk sac inside the embryo, creating what we call the primitive gut tube. This is the starting piece for our entire assembly line. So what's this primitive gut tube actually made of? Well, you can think of it as being built from 3 essential raw materials, or germ layers, and each one has a very specific job to do. Let's check out the parts list. The inner layer, the endoderm, that's what forms the delicate inner lining and all the glands. Then you have the middle layer, the splanchnic mesoderm, which builds the strong muscular walls. And finally, you've got these specialized neural crust cells that migrate in to create the gut's very own brain, the enteric nervous system that eventually controls all our digestion. Now, our assembly line is broken down into 3 major stations. And here's the cool part. Each one has its own dedicated, unchangeable power source, its arterial supply. The foregut is powered by the celiac trunk. The midgut gets its juice from the superior mesenteric artery, and the hindgut is supplied by the inferior mesenteric artery. This division is absolutely fundamental. It's locked in from the very beginning, and it never changes. And here we are pulling into our first major station on the line, the foregut. This is where the first parts of the upper digestive tract get crafted with some incredible precision. And just look at the list of products coming out of this station. It's responsible for a whole bunch of crucial organs: the esophagus, the stomach, the first bit of the small intestine, and even key accessories like the liver, gallbladder, and pancreas. Fun fact, even the spleen, which isn't technically a digestive organ, develops right alongside them here. Now, if there is one number, just one number you need to remember for the foregut, it's this one right here, 90 degrees. This single rotation is the key to creating one of our most recognizable organs. So how does that 90-degree turn create the stomach's classic J shape? It's actually a beautifully simple 2-step dance. First, the stomach tube rotates 90 degrees clockwise. Then, its back wall just starts growing way faster than the front wall. This uneven growth is what pulls and stretches the organ into that iconic shape with the greater and lesser curvatures that we all know. Now, while the stomach is being shaped, the next part of the line, the duodenum, is going through a really weird process. For a little while, the tube, or the lumen, it actually gets completely filled in with cells. It becomes solid. This is called obliteration. Then it has to be hollowed out all over again, and that process is called recanalization. And this step really shows you why quality control is so critical. See, if that recanalization step fails, if the tube doesn't get hollowed out again, it stays blocked. That condition is called duodenal atresia, and for a newborn, it's a very serious medical problem because no food can pass through. Okay, moving on to station 2, the midgut. If the foregut was all about precise little crafts, the midgut is all about drama and large-scale mechanics. This is where things get really dynamic. Yeah, forget 90 degrees. The key number for the midgut is an absolutely staggering 270 degrees. This is the angle of a massive twist that is going to define the entire layout of our abdominal cavity. So how on earth does this happen? Well, first, the gut loop is growing so fast and the liver is so huge at this point that there's literally not enough room in the abdomen. So it temporarily pops out into the umbilical cord. While it's out there, it performs this massive 270-degree counterclockwise twist around its power source, the SMA. Finally, once the rotation's done, the whole loop pulls back into the abdomen, where it folds and settles into its final spot. Just incredible.
And the end result of that amazing rotation is the perfect placement of a huge chunk of our intestines. This one single process is responsible for positioning everything from the rest of the small intestine to the appendix, the ascending colon, and even the first 2/3 of the transverse colon.
And that brings us to our final stop on the line, the hindgut. This section's job is to finish up the whole process and make all the final connections.
Now, the very final exit of our assembly line, the anal canal, has this really unique story. The upper 2/3 actually comes from the internal stuff, the hindgut endoderm, but the lower third, that forms from the external surface of the embryo, the ectoderm, and these two very different tissues meet up at this landmark called the pectinate line. It's literally where the body's inside world meets the outside world.
Early on, there's just one common chamber for both waste and the reproductive system, and it's called the cloaca. A really crucial step in the hindgut's development is when a wall forms and divides this chamber, cleanly separating the digestive tract's exit from the urogenital system.
So, we've seen the assembly line working perfectly. But what happens when a step goes wrong? This final section on quality control is so important for understanding how all these developmental steps are directly tied to clinical medicine.
And this table right here brings it all together. This is your high-yield summary, linking each station to its power supply and a classic quality control failure. A glitch in the foregut can cause a tracheoesophageal fistula, an abnormal link between the windpipe and the esophagus. A midgut error can leave behind a Meckel's diverticulum, a little pouch in the intestine. And a problem with the hindgut can cause an imperforate anus, where the opening isn't formed correctly.
You know, when you take a step back and you look at the whole process from start to finish, it's just awe-inspiring. This isn't just a random set of steps. It's an elegant, incredibly refined blueprint that's been perfected over billions of years of evolution, and it just runs automatically inside every single one of us. And that brings us to a final thought. We've seen just how beautiful and precise this whole assembly line is, but it also shows you how fragile it can be. It really makes you wonder, in a system this complex, what are the cascading consequences when just one tiny instruction in this ancient blueprint goes wrong?